You are welcome to this channel. So today we want to integrate the arcsin x. If you look at this expression very well, you can see that we cannot use substitution method to integrate it. Now, the next thing that you have to do is that you multiply the expression inside the integral by 1. So, integral of arcsin x, then multiply by 1 dx. If you multiply 1 by any expression or any number, it's as if you are not multiplying anything with it because it gives you the same thing as the initial expression. Now, having done this, you can see that it's now in product form. So, and the product rule for integration is called integration by parts. And the formula for integration by parts, integration by parts. The formula for it is that integral of u dv is equal to uv minus integral v du. The next thing here is that which one am I going to take as my u and which one am I going to take as my dv? Do not have to bother. Just use this acronym ILATE, where E stands for inverse, L for logarithm, A algebraic, C trigonometry, and E for exponential. So this acronym will assist you to know which one to take first, which expression to take as your u and which one to take as your dv. Now, from this one now, you can see that this is constant. This one is constant, so it's not here. So the one that we are going to take as our u will be the arcsin x because that is the inverse. It's even the one that comes first in the acronym. So our u is equal to arcsin x. Now, the u, the x, is equal to 1 over square root of 1 minus x squared. Now, the v is our 1. The v is equal to 1, then multiplied by the x. So if you want to find v now, you have to integrate both sides. So if you integrate both sides, integral of this one gives you, if you integrate the v, it gives you v. If you integrate constant, it gives you x, then plus c. Now, having done all this, then you have to substitute all the values gotten inside the formula for integration by parts. So we have integral of u is arcsin x, then the v is 1, the x is equal to u is arcsin x multiplied by v is x minus integral over v x, then the u is 1 over square root of 1 minus x squared, then the x. So it can be written as arcsin x. The x is equal to x arcsin x minus integral of x over square root of 1 minus x squared dx. Now, the next thing is that we have to integrate this part, integral of x over square root of 1 minus x squared dx. So let's take that from here. We have integral of x over square root of 1 minus x squared dx. So for this one, we can now use substitution method. So let 1 minus x squared to be equal to t, or any alphabet that you like. So you can now say that the x is equal to minus 2x. So let's substitute it here. So from here, okay, we need to make the x the subject of the formula here. So we have the t is equal to minus 2x dx. So divide both sides by minus 2x. Minus 2x, we have minus 2x cancel minus 2x. So the x is equal to minus the t over 2x. So let's substitute everything inside this expression. So it gives minus integral over x over square root of t multiplied by minus the t over 2x. So here x, we cancel x, so we have 1 over 2. If you take this 1 over 2, you know it's the denominator, so we take it out. So we have integral of and this minus also, we take minus out. So we have integral of 1 over square root of t, then dt. So it gives minus 1 over 2. So integral of t raised power minus 1 over 2 dt, which gives minus 1 over 2. So if we integrate t raised power minus 1 over 2, it gives t raised to the power of minus 1 over 2 plus 1 over minus 1 over 2 plus 1, then plus c. So which is the same thing as minus 1 over 2 into bracket minus 2, or minus 1 over 2 plus 1 gives 1 over 2. So t raised power of 1 over 2 over 1 over 2 plus c. So it gives minus 1 over 2. So if you simplify this one, it gives 2 multiplied by t raised power 1 over 2, then plus c. It has minus t raised power 1 over 2 plus c. And recall, you have to recall that our t here, we use our t to be equal to 1 minus x squared. So recall that t is equal to 1 minus x squared. So anywhere you see t now, you are going to substitute it with 1 minus x squared. So this one gives minus 1 minus x squared raised to the power of 1 over 2 plus c, which can also be written as minus square root of 1 minus x squared plus c, because of this exponent, which is 1 over 2. Now, also recall that our initial integration is integral of arcsin x dx, which we have gotten x arcsin x, then minus integral of x over square root of 1 minus x squared dx. So recall that this one is the same thing as integral of x over square root of 1 minus x squared dx. That means anywhere we see the integral of x over square root of 1 minus x squared, we are going to put minus square root of 1 minus x squared plus c there. So this one gives integral of arcsin x dx is equal to x arcsin x, then minus into bracket minus square root of 1 minus x squared plus c. So let's simplify this one now. So we have the integral of arcsin x dx is the same thing as x arcsin x minus times minus will give us plus. So plus square root of 1 minus x squared plus c. So that is the answer of integral of arcsin x. So till I see you in the next class, thank you and bye bye.